Hello and welcome to another video in Foundations of Maternal and Newborn Health. In today's video, we're going to continue from where we left off in the last video on Mendelian genetics. Mendelian genetics, so we'll call this MendelianGenetics2, and this is specifically probabilities. Okay, so in the last video we talked about dominant and recessive genes, and we talked about eye color and freckles. In today's video we're going to go into a little bit more detail on how we can use our knowledge of dominant and recessive genes to guess the probability of a baby having a specific disease. So we talked about how eye color can either be brown or blue, and that's great for her guessing the eye color or other physical traits of a baby, but this is more useful for predicting diseases. Predicting, I guess, chance of disease in a baby. So the example we'll talk about today is cystic fibrosis. Cystic fibrosis. Okay, and cystic fibrosis is a recessive gene. So again, that means that you have to have both copies of the cystic fibrosis gene to actually have cystic fibrosis. So we'll call this the little f gene. And the healthy gene will give big F. So to have cystic fibrosis, you need to have both copies from both your mom and your dad being the cystic fibrosis gene. Okay. So let's say we have parents and they're both carrying one copy of the cystic fibrosis gene, but their other copy is healthy. So both parents are healthy, they don't have cystic fibrosis. So let's say the father, he's going to be big F for that healthy gene, and then little f for that cystic fibrosis gene, and he's going to be healthy. Okay, so we're going to draw his genes up here, F and little f. And we're going to draw this as a table. So the mother's genes, she's also big F, little f. So we'll draw that in here, big F and little f, and she's also healthy. Because she has a copy of that healthy gene. That healthy gene is dominant. The healthy gene is dominant. Okay. So I'll explain a little bit about how this table works first. So if I draw a dotted line here and a dotted line here, this makes 4 quadrants, right? We have kind of a quadrant up here, a quadrant over here, a quadrant over here, and a quadrant over here. And each of these squares within this table, each of these quadrants, are a potential baby. Not a real baby, but a baby that the father and mother could have. Okay? And we'll draw the potential genes that the father and mother could give the baby. So drawing down from this big F from the dad, he could give the baby that healthy F here and here, or he could give the baby the little diseased F, the recessive cystic fibrosis gene. So he can give the baby the disease gene, or he can give the baby the healthy gene. The mother can do the same, but this time we're going to work in this direction. So the mother can give that healthy gene, the non-cystic fibrosis gene, or she can give, in this direction, the diseased cystic fibrosis gene. Okay, so we know from the last video that dominant genes are the ones that show up. So big F and big F, this is the healthy gene, this is the dominant gene. So FF, big F and big F, this baby is going to be healthy. Big F and little f, again, that healthy gene is dominant. So even if they have that cystic fibrosis gene, if they have the big F, the baby's still going to be healthy. If the baby in the bottom right quadrant is born, if this baby with the two small f's is born, so little f and little f, this baby will have cystic fibrosis. So this will be a sick baby. Okay? And so we can write out the probability of these happening by taking the number of times it happens divided by the total number of possible babies. So this big F, this is a 1 chance out of 4 possible babies. This little f is also 1 out of 4. And this big F, little f is 2 out of 4. 2 out of 4. And then we can convert this to a percentage. So the chances will combine the two healthy. So the chances of the healthy baby being born is 3 out of 4, which is the equivalent of 75% chance. So there's a 75% chance that if this father and this mother get together, they'll have a healthy baby. And it may have kind of this cystic fibrosis gene that it's still carrying, but overall the baby will still be healthy because it's got the dominant healthy gene. The chance that they have a sick baby with cystic fibrosis is 25% chance. There's a 1 in 4 chance that this baby ends up with cystic fibrosis. So this is a CF baby. Okay? So this is why this is valuable to know these dominant versus recessive genes. If you know what the genotype is or what the genes that the father and mother have, you can actually estimate or guess the chances of them having a healthy or sick baby. So we'll go through another example with you and hopefully you can answer them as we go along. Okay, so for this example, we'll use the disease sickle cell anemia. Sickle cell anemia. And sickle cell anemia is also a recessive gene. Recessive. Which means that you need to have both copies for the disease to show up. And we'll give this a small a for anemia. The healthy state, the healthy gene, which is dominant, we'll call big A. Okay, so let's do a Punnett square or probability table. Okay, so let's say that the father is healthy. And the father is actually going to have 2 big A's. Big A and big A. So he has 2 healthy genes. The mother, on the other hand, the mother has sickle cell anemia, or SCA. So she's sick with sickle cell anemia. So she, of course, it's recessive, so she has 2 small a's. Okay, so pause this video and fill out this table, and then you can unpause it and see if you get the same answer. Okay, so hopefully you paused it and you filled out the table, and we'll go through what this answer looks like. Okay, so again, each of these squares that I've just drawn in is a potential baby. The father is always going to give a big A. because he only has these healthy A genes. So we're going to give 2 big A's. The mother only has the disease gene, so she'll be giving the baby small A's. And so this is a really easy Punnett square because the baby can only be big A from dad and little a from mother. So this is 100%, or 4 out of 4, which is 100% of their babies will be healthy or will not have sickle cell anemia specifically. Okay, because that dominant healthy gene, that big A, the father is always going to give at least 1 copy to the baby, and the mother is always going to give the disease copy to the baby. But because it's recessive, the father's healthy gene will keep the baby healthy, or at least prevent it from having sickle cell anemia. So hopefully you got the same answer as I did, and you can imagine, you can even practice yourself drawing different gene combinations. If dad has 2 little A's and mom has 2 big A's, or one has a big A and a little a and the other one has 2 little A's, you can play with what the probability of each of these combinations of genes would give you in terms of their probability of their baby being diseased or healthy.